All right, we're going to do our next limiting reaction problem. We have diiodine pentoxide plus carbon monoxide yields carbon dioxide and iodine, probably a liquid if it's room temperature. Okay. They give us that there's 80.0 grams of I2O5 and 28.0 grams of carbon monoxide. So neither one is in excess, which means we have to figure out what's the limiting reaction before we go on. And we do know that there was 0.16 moles produced to I2. That's why I picked I2 for my stoics, because if I pick carbon dioxide, then I'd have to do another stoic on top of it. And I'm trying to reduce the amount of stoics that I need to have. Okay, so the first thing that you have to do is you have to balance the equation. Okay. So when you balance this equation, I can tell you right now, it's going to be a problem because it's an odd, an even, plus an extra oxygen over here. So you might have to go through multiple times in your attempt to balance this one. I'm going to tell you how I do it. This is not necessarily the best way because I go back and forth on these two. I know it's an even and odd, so I'm going to multiply them together to get the least common multiple, which is 10. And then I'm going to put the 10 over here. That's going to tell me that I need 20 oxygens on, I have 20 oxygens on the right, and for conservation of mass, I need to get 20 on the left. Okay, but you can't put a 4 times 5 here because then you're forgetting about that guy. And also, you have carbon that is attached in there. It's not just plus O2, so it's limited on how far it can go. So I know since I have a 10 here, I have to put a 10 there so that my carbons are balanced. So right now my iodines are balanced and my carbons are balanced, but my oxygens are probably way all over the place. So let's see what I get here. Now I have 10 oxygens, 15 oxygens versus 20 oxygens. All right, so that means I need to add it by more 5. So I'm gonna put a 2 there. If I put a 2 there, I also need a 2 here. Now I have 4 iodines, 10, 20 oxygens, 10 times 2, 20 oxygens, 10 carbons, 10 carbons. But as you can see, I have everything is even, which means I now have to go through and divide everything by 2, because it meant I did one extra step. So if you can do it without doing the extra step and then having to simplify, great. That'll save you a little bit of time. So now I know that there's 1 I2O5 plus 5 COs yields 5 carbon dioxides and 1 iodine. I know I start with 80 grams of I2O5. And I know I'm always going to go to moles. And then I know that I am going to have to use my mole ratio. 1 mole of I2O5 gives me 1 mole of I2. So remember to simplify because that's going to help your equation over here. And then I'm going to have to go from moles of I2 to grams. Okay. My second equation takes my second reactant, 28.0 grams of carbon monoxide, grams to moles. I have 5 moles of carbon monoxide for every 1 mole of I2. And now I have 1 mole I2 to grams. So again, you're going to see lots of those similar things. I lost my periodic table. All right. Iodine is 126.91. So 2 of them gives me 253.82. Remember, 2 decimal places. And that's the same on both sides. We're both trying to find the moles to the grams, the moles to the grams. So that last step is the same. Okay. Now I2O5, that's 2 I's plus 5 oxygens, 5 times 16. That gives me 333.82. And carbon monoxide, 12.01 plus 16. 20, oops, what am I doing? 28.01. I'm looking at the calculator and not where I'm writing. So anytime you go grams to moles, you're always dividing, remember, because we have to get rid of the grams. So Your masses from periodic table have to be there. So let's see, 80 times 1 times 1 times 253.82. I'm only dividing by one thing, so divided by 333.82. And 3 sig fig, 60.8 grams of I2. So if I have 80 grams of I2O5, I get 60.8 grams of I2. How about if I have 28 grams of carbon monoxide? 28 times 1 times 1 times 253.82 divided by, make sure you use brackets, quantity of 28.01 times 5 and bracket, and that gives me 3 sig figs, 50.7 grams of I2. Well, that one's closer, much closer than some of the other ones we've been doing. So if I have 28 grams of carbon monoxide, I get 50.7 of I2. So then I run out of carbon monoxide. So I'm now brought that 28 to nothing. That means it doesn't matter that I still have more I2O5 left. I can't make the reaction go anymore. So the reaction stops here, making this my theoretical yield, how much I physically can make with both of these. I can't make 60.8 because we stopped, or we're limited here. That makes carbon monoxide my limiting reaction, and I2O5 my excess reaction. All right, so now we have that first part. We have the theoretical yield. Okay, now we got to figure out how much do we use. Stoic, the limiting reaction to the excess reaction, 28.0 grams. Carbon monoxide, that's our limiting. Has to go to moles, 28.01 grams and 1 mole, so I can just steal that right there. And now I'm going from carbon monoxide to the excess I2O5. There is 5 carbon monoxide moles to 1 I2O5 mole. And now I got to make that guy into grams. So 1 mole of I2O5 is how many grams? I think I did that calculation somewhere. Yes, I did, right there. 333.82. This really helps you on time tests, because it does tend to take some time to get through all that. Okay, 28 times 1 times 1 times 333.82 divided by the quantity of 28.01 times 5 and quantity, 3 sig figs, 66.7 grams I2O5. That means that is my exact amount needed. What does that mean again? It means that if I have 28 grams of carbon monoxide, I'm going to use up 66.7 grams of I2O5. At that point, the reaction stops. And I now need to figure out how much extra I2O5 did I have? How much extra? Well, I started with 80 grams, and I used 66.7 grams, so I just need to subtract that. 80 minus 66.7. 13.3 grams are in excess or leftover of I2O5 because I couldn't keep going and using them. Okay, next thing I had to find is what is my percent yield. So I started out with my experiment gave me from the question 0.160 moles of I2 was produced. So let me change that into grams. Okay, that's 253. Okay, 0.16 times 253.82 gives me 40.61, oops, just 3 sig figs, 40.6 sorry, let me move that up. 40.6 grams of I2. Okay, that's what the lab gave me. So that's what the experiment gave me, or that's called the actual yield. What is my theoretical yield? 50.7. Part over whole, 40.6 over 50.7 times 100% gives me how good my collection was. 40.6 divided by 50.7 times 100, 80.1% yield. Yield is how much I collected. I was able to collect 80%, which is actually pretty good.